All right. So we left off on Tuesday talking about spanning trees. Remember, we said spanning tree meant if I have 6 dots, they should be connected by 5 edges. My edges should be one smaller than my dots, okay, or my vertices. So if you take a look at 1A, how many vertices do I have?
Yes, 6. 7.
Yes, 7. Right now, how many edges do I have?
8.
7.
1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 edges. Okay, so just looking at that picture, is it a spanning tree? No. Okay. A spanning tree says I need to be able to connect my 7 vertices with only 6 edges. Remember, my spanning tree shouldn't have any circuits. Nothing closed off. It should just be reached out to. Okay? So, I need to somehow get this down to 6. So, how do I make 9 into 6?
3.
Divided by 3.
Not divide.
I mean, subtract.
Thank you. We need to get rid of 3 of those lines. Okay? I need to get rid of 3 of those lines. Which lines would you like to get rid of? Remember, we need, hold on.
Sorry.
I'm totally game. Remember, my goal is I need to get rid 10. I want white.
2. Okay. I am 2.
Okay, so remember, when I'm getting rid of these 3 edges, I'm trying to get rid of edges that close my figure off and create circuits. So, Devin, give me one edge I want to get rid of.
A to D.
A to D. Okay, we can get rid of that. Woo! I went a little too far.
No, you're good.
Okay, so I need to get rid of 2 more. What do you want to get rid of? You said D to C. Okay?
F to C.
And F to C. That works.
F to C.
Okay? So if I get rid of those 3 lines, I no longer have any circuits. So now I have 7 vertices and I have 6 edges. This is now a spanning tree. Okay? So where it says find the spanning tree in the graph, that's what you're going to draw, what you have left. So here to here, here to here, here. We went around that way. You've now just created a spanning tree. You figured out how many edges you needed to get rid of. Bada bing, bada boom. You're right. Bada bing, bada boom.
So it always has to be 6?
Yes. When you have a spanning tree, your vertices should always be 1 more than your edges. So that's how you determine how many lines you actually need. Okay. So take a look at 2A. How many vertices do I have in this picture? 7. How many edges do I have in this picture? 6. 1, 2, 3, 4, 5, 6.
So we're good.
So is this a spanning tree?
Yes, that is a spanning tree.
Yes, this is a spanning tree. Okay? So guess what? I don't need to do that second part. It's already a tree. It's already a tree. Genius! Okay, so, excuse me. This is one way to find how many lines I need to get rid of. And of course, you know, it's math class. There's a formula for that. Okay? So, redundancy. Your redundancy formula will tell you how many lines you need to get rid of. Okay? So, your redundancy formula is the difference of edges and vertices plus 1. So in other words, R equals, how do I write the difference of edges and vertices?
E minus V.
E minus V. Edges minus vertices plus 1. If you use this formula to find redundancy, if you end up with a value of 0, that means I have a tree. Yay! If it's greater than 0, you should never end up with a negative number. You did something wrong, okay? If it comes out to be greater than 0, so your redundancy formula is great. It tells you, yes, I have a tree. It tells you, no, I don't. But what it doesn't tell you is what you need to get rid of. Okay, so that's our problem. So if I would back up to where we just left off. So here, we said my edges was 9, and my redundancy formula is edges minus vertices plus 1. So that means we would have done 9.
Minus 7.
Whoops, sorry, minus 7, not plus 7. 9 minus 7 plus 1. Well, what's 9 minus 7?
Yeah. Oh my God, it's 2.
Oh my gosh, it's 2. Plus 1, 3. How many did you tell me we needed to get rid of? 3 to make it 6. Okay. So you've already kind of done it, but this is the formula you would use. If you do this one, again, edges, so 6 minus vertices, 7 plus 1 equals, well, 6 minus 7 gives me negative 1 plus 1 is 0. So my redundancy here is 0, which tells me I have a tree. Okay. So just 2 different ways to look at it. Okay. Questions? All right. So how do you find a spanning tree? Your job is to first figure out how many you need to remove. And then look at number 2. Do not remove any edges that are ridges. You don't ever want to separate and disconnect your graph. So that means I cannot get rid of A to B. I can't get rid of B to C. I can't get rid of D to E or D to G or G to F. Okay, so we're going to use our redundancy formula.
Basically, you can't get rid of, you can't break off C, H, and D. You can't break off because that's like
you're getting rid of your circuits. That's your goal, is to disconnect your circuits. Okay, so E minus V plus 1. Let's see how many edges I need to get rid of here. Okay, how many edges do I need to remove? How many edges do I have right now?
1, 2, 3, 4, 5, 6, 7, 8. You got 8 vertices.
I have 8 vertices. How many edges?
1, 2, 3, 4, 5, 6, 7, 8 edges. You got 8 edges.
Okay, I have 8 edges minus 8 vertices plus 1. What do you get?
It's 1.
1. Okay, so according to my redundancy formula, I need to remove 1 edge. Okay, we already said that I can't remove any bridges. So I can't remove this, or this, or this, or this, or this.
C to D. I say C to D.
So how many options do I have that I can remove?
D to H.
Yeah, you have 2.
I can remove C to H.
Or C to D.
I could remove C to D.
H to D.
And I can remove H to D. So I have 3 options.
That's why I was saying that truth.
I can remove any 3 of those because they've created what?
That's right.
Circuit.
They've created a circuit. So whenever you only have one circuit in your graph, you have however many edges you have in that circuit that can be removed. This is a circuit of 3 edges. So I can remove any 3 of those. Okay. Questions? Okay. Take a look at this one. We added on one more line that connected F to E. Okay. So I now have how many edges?
9.
I now have 9 edges. Minus 8 vertices plus 1. I need to remove 2 edges now.
You remove F to E and C to D, right?
Okay. So I need to remove one edge that causes this to no longer be a circuit. So how many options do I have to remove in this one?
4. Why do you have 3?
Because I have 3 edges in that circuit. 1, 2, 3.
And G, D.
We're not on that circuit yet. Hold on.
Okay.
Hold on.
That's
Hold
a
on.
whole other circuit.
Okay.
baby.
So I can remove C to D.
Turn it off.
I can remove C to H. I can remove H to D. Okay? I can remove any one of those lines in that circuit. How many options do I have in this circuit?
4.
I have 4 now. Okay? So I need to remove 2 edges. I need to remove one from this circuit and one from this circuit. Guess what? I've got 3 times 4.
12.
I've got 12 different ways I can do that.
What if you just move H to D, G to D?
Okay? So, in other words, let me see if I can. I don't want to lose anybody here. I'm trying not to. I'm trying really hard not to. All right. So, I need the thicker one. Okay. So, my first column, I said that I can remove C to D in this one. Okay? So I need to remove one from that circuit, and then I've got how many options in that second one? 4. I got 4. Okay. I can remove that, and I can remove C to D. Or I can remove C to D and eat it. Oh, wasn't supposed to do that.
Oh, I don't know about to look now. Ooh, I wish I did. I'd be like, I'm
Okay.
going.
Or I can remove E to F. So when I remove C to D, I then have 4 options to remove the other ones. I can remove D to E. I can remove E to F. I can remove G to F. I can remove G to D.
That's easy, man, but it's a lot of writing, man.
Okay, so let me tell you this. You're not actually going to ever have to list them out.
Oh.
I'm going to give you like how many edges you need to remove, and then you'll see how many spanning trees do you have then. So you're going to have to use this part of it. You'll never have to list them all out. So this lists out your 12 options. I can do C to D and all the options in that one. Or I can remove C to H, and guess what? All 4 of those options again. I can remove H to D, and again, all of those options. There's one more case that I've got to show you, and that's it. Okay. So in this one, you're worried about how many options you have in one circuit, how many options you have in the second circuit. Multiply them together. That'll give you the total options you have all together. So there are 12 different spanning trees in this picture. Okay. There's 12 different ways that you can remove 2 lines to create a spanning tree. Alrighty then. Okay, so take a look at that picture again. And then we're going to go to this one.
This one looks hard.
This one looks hard.
They added another one. It was H to G.
Okay. So, how many edges do I have in this one? How many edges are in this picture?
2, 6, 9.
9. Minus how many vertices?
8. I'm assuming.
Plus 1.
2.
We're at 2 again. Okay. What's the difference between this picture and this picture?
They connected H and G.
So instead of doing G to D, they've moved that line so it connects H to G. So do I still have 2 circuits?
Yeah.
Yeah.
Or is it?
I have 2 circuits, but what does this circuit have that this circuit didn't? A what?
A better drawing.
No.
It has H to G. That's an extra line.
No.
Yeah,
It still has 9 lines.
Oh, no,
What's the difference between this picture and
You can
this?
easily get rid of C and D.
Hold on.
I can easily get rid of C to D no matter what.
Okay, when do you want it? Okay, go back to the. Oh, it's right here.
It's right there in front of you.
It's got the octagon.
It's about an octagon. Okay.
You give us a hint.
Take a look at, how do I put this? Take a look at your 2 circuits here.
It's like one big circuit. That's what I was thinking at first.
Okay.
That's what
So this has kind of become one big circuit, which means they do what?
It's just one.
They share a,
Line.
they share a line in common now.
H to D.
See how these 2 circuits were separated? Okay, they were 2 separate circuits. These ones are still 2 circuits, but these 2 circuits share a line in common. So, how many lines is my first circuit? C, D, H, C. How many edges are in this circuit right here?
3.
3. How many edges are in this circuit? 5. Okay, so my last rule said I should take 3 times 5, right? 3 times 5, which means I should have 15. I'm going to tell you that that's wrong. I should only have 14. Okay, watch. Watch what happens. So I can remove C to D. That's getting rid of that circuit of 3. Then I can remove either D to E, E to F, F to G, G to H, or H to D. Okay, instead of removing C to D, I can remove C to H. And again, I can remove D to E, E to F, F to G, G to H, or H to D. Then my last option for this circuit of 3 is H to D. And then I can remove D to E, E to F, F to G, G to H, and H to D. What's the problem? Look at that chart and tell me what my problem is.
You have an extra set of on the bottom. Oh wait, is that right?
I have an extra set of what?
I should call
That's 15 right there.
That is 15, but my answer should be 14.
That's your problem.
them. Shut up.
But which one goes away?
FG.
Wow. Why FG?
Oh no, H to D.
H to D.
Because it was a
Look
lot.
at my last column. If I remove H to D in this first circuit, I can't remove it again. Okay, so because this one shares a line in common, yes, we multiply 3 times 5, but I have to subtract 1 to get my final answer. Because I cannot remove the same line
So this is
twice.
like a trick question.
No, not necessarily.
I like this story.
All right, so we are going to practice on finding how many spanning trees you have. Okay, so first thing you need to do is you need to look at the picture and say, how many circuits do I have? In graph 1, I have 1 circuit. If I only have 1 circuit, the amount of spanning trees I have are how many edges that circuit contains. So here's my circuit. How many edges is that? So I have 4 spanning trees. Those are the easiest ones.
So you get 2, that's 4.
Okay.
That's 5. That's
Look at number 2.
No.
How many circuits do I have?
2.
I've
4
got
and
2.
5. That's
I've got
9.
2 circuits. Okay. This circuit has 4 options. This circuit has 5 options. So to get my final answer, 4 times 5,
4 times 20.
I've got 20 different options.
I did not. I said
Oh wow.
Ew.
There's 20 different spanning trees.
That's 4.
Okay.
That's 2 different, and that's 4, and that's 3.
Now, because these 2 circuits that I had didn't share any edges in common, that's why I just multiply, and that's my answer. If you take a look at number 3 now, I still have 2 circuits, but they share an edge. So this circuit has 4.
And that was
This circuit has 3. But this time, I take 4 times 3 and get 12
And get 11.
and subtract 1 to get rid of that edge that I can't use twice.
Man, it's easy, man. Simple.
Alright, we got
I'm wearing a low sleeve shirt and a jacket.
Okay? Take a look at 4. How many circuits do I have?
You got 3, 4.
Yeah.
You
I have
got 4.
4 circuits.
That's 4, 5, 3, and 3.
Okay? So this one has 4.
Nah.
This one has 5.
Tricks.
This one has 3.
And that one has 3.
And this one has 3.
So it's 4 times 5, which is that's not how it
Do we
works.
do 4 times 5 times 3 times?
Okay.
3 times
So
3 is 9.
when you have ones
And 5 times
that
4
have
is 12.
something that shared an edge and then stuff that does not, you must do what shares an edge first. So
9.
here we would do 3 times 3, which
It's
is
9.
9,
And make that 8.
minus 1, which gives me 8.
And 4 times 5 is 20. And then you do 20 times 8.
So now this becomes 4 times 5 times 8.
Oh, shit. I mean, shoot.
Well, I know that's 20. 20 times 8 is 2 times 8 is
It's
16.
160.
160. Shut up, bro. I would have got it.
There's 160 options on this one.
Yeah, well, I'm not.
That's it.
So be
No.
careful with that.
We got the last one, y'all.
Okay? Number 5.
I can't see it.
I'm sorry.
No, you're good. I didn't want
4 circuits.
Somebody else can do it.
Okay?
Or is one of this?
This circuit has 3. This circuit has 5.
It's fat.
This circuit has
So,
4.
That one had 3.
And the last one has 3. Notice
Oh,
3 and
sure.
5 share an edge.
and 4 and 3.
4 and 3 share an edge. So we need to do both of them separately first
3 times
and
5.
then multiply it together.
15. 3 times 5 is 15. Minus 1 is 14. 4 times 3 is.
Whoa,
12.
slow down. Back up. Woo!
But you got it. Though.
I'm so glad you got this, but back up. Okay?
4 times
So
3.
3 times 5, that would have originally given me 15 options. But I can't count that one edge twice, so that takes me down to 14. My second one, 4 times 3, should have given me 12.
Minus 1 is.
Again, I can't use that edge twice, so we have to subtract 1, which gives me 11.
What's 14 times 11, y'all?
And then we take 14 times 11. It's not 141.
Where's the photo? Sacramento.
People have calculators.
14 times 11.
154.
See, don't put your phone up now. Like, I just asked you to calculate a problem. Bro, that must be.
154.
His phone must be freaking.
Okay. 2 more. 2 more. Take a look at number 6.
That's 3 circuits.
3 circuits.
4, 3, and 5, 6.
You said 4,
4, 3, 6.
3, and 6. Does any of them share any edges in common? No, so it's straight multiplication.
4 times 3 is
4
12.
times 3 times 6.
What's 12 times 6, y'all? Isn't that like 60 or 72?
72.
Well, let me find out this dude.
All right, Devin.
Oh, thank you.
I was joking.
Okay, hold on.
Try this last one on your own
Oh, yeah.
before I go over it.
In
your head, Devin.
Well, I mean, I don't want to do it out loud because I don't have no paper. Okay, it's okay. 4, 4, 2, 3, 4, 5, 6, 3, 4, 5, 4, 4.
Oh shit! Shoot.
Okay, I got it. I got it. Don't fall asleep now.
What is it? How you use it?
Okay. Oh, hold on, wait.
I need to try. You got the jar?
Yeah.
How you?
Oh. That is fantastic, Maya.
First one.
Woo! Go Maya! Go Maya!
You got a plug?
Yeah.
There you go. There you go. Woo woo!
Oh, wait.
Yes. You're on the right track. So now you've got that one. And then multiply it by the other two that you have.
still got it wrong.
Back to this.
I was gonna say you still got it wrong. Like,
Oh, wait, what you do?
it's okay. What you're gonna do?
Mm-hmm.
Straight jacket.
What you get?
What's 4 times 4?
Oh yeah, we got. Debbie, you might be
Because you
wrong.
just added that. Crazy.
16.
Fix that. You just added that on me. That's fantastic.
What do you mean I got it wrong?
Go.
You might got wrong, bro.
You actually paid attention.
What did you do though?
Oh.
What did you do?
That's 4. That's 4. Then that's 4, and that's 5. And then that makes 16. Minus 1 makes 15.
Line that they share.
Times that by 4, and then times that by 5.
These don't have a line.
That should equal.
So that'll just stay. See how these two share this line? These two, there's nothing there. So keep that as 2. Alright.
I'm at my time.
Whoa! Coming through into my zozo. Oh, yes.
I know it's 3 times.
That's great. Fantastic. All right. So let me go over this real fast, and then you can start on your work. So, number 7, we have 4 circuits. Okay. We have 4 circuits. We've got a circuit of 4, a circuit of 4. This is a circuit of 4, and this is a circuit of 5. Okay. These two share something in common, so we've got to do that first. So 4 times 4 gave us 16, but we have to take away that edge that they share in common. So I've got 15 options here. Then I've got 4 options and 5 options. So you should have, there's 300 different ways to write a spanning tree in this picture. So every one of you in this class can have a different spanning tree.
Oh, I was right.
About
I told you.
8 different times.
I told you it was 300.
I know. I'm saying. I don't know.
Question.
Oh!
Can you set this back? We only subtract when they share.
When they share an edge in common.
All right.